In this video, we're going to talk about how to solve logarithmic equations. So there are two rules we're going to be using. One is the definition of logarithms. So for instance, if you have log base a of x is equal to y, then we can write this in exponential form as a to the power y is equal to x. So that's one of the rule we're going to use. And the second one we're going to use is if you have log base a of x is equal to log base a of y, then this just means we can set x equals to y. Now both of these can be rewritten using natural log. So if you remember, we denote natural log using ln and the base is e. So for the first one, we can modify it as if you have ln of x is equal to y. So we know ln has base e. So you can rewrite this as e to the power y equals to x. Similarly, the second one, we can rewrite the logarithm using natural log, which is ln. So if you have ln of x is equal to ln of y, we can simply say that x is equal to y. So we're going to be using these two rules to simplify and to solve logarithmic equations. So let's take a look at our first example. So here's our first example, and we want to find the solution to this equation. So I'm going to be using the definition of logarithm. So here's my base, and let's suppose our input is 2 minus x and the output is 3. So we can write this as 3 to the third power is equal to 2 minus x. So we use the definition to rewrite in exponential form. Now we can just go ahead and solve for x. So I can go ahead and do the 3 cubed, that would be 27, is equal to 2 minus x. And then I can go ahead and add x to both sides just to move them around. So let's go ahead and add x to both sides. So we have x plus 27 is equal to 2. And then finally, I can go ahead and subtract 27 on both sides. And that would give us x is equal to 2 minus 27. That would be negative 25. Now with logarithmic equations, you always want to check your answer. So let's plug this into the original and check. So if we input negative 25, we have log base 3 of 2 minus negative 25. Is that 3? Well, because this is positive, so the check is complete. You just want to make sure that the input value of any logarithm is always positive because of the domain. Okay, so we'll say yes, x equals negative 25 is a solution. All right, let's take a look at our second example. So here's another example. Again, we're going to be using the definition to rewrite. So I'm going to go ahead and try to isolate the expression with logarithm, which is this piece right here. So we're going to have to subtract 4 first. So let's go ahead and do that. So we have 3 log of 2x is equal to 16. So 16 minus 4 will give us 12. And then I can go ahead and divide both sides by 3. So we have log of 2x is equal to 12 divided by 3, that would be 4. And now we can write this in exponential form. So if the base is not written, we know this is a base 10. We call it the common base. So we have 10 to the 4th power is equal to 2x. So now we can just go ahead and solve for x. So we have 10 to the 4th, so that would be 1, 2, 4 zeros, right? So that will be 10,000 is equal to the 2 times x. And then I can divide both sides by 2. So that would give us 5,000 is equal to x. And then we're going to go ahead and plug this in to check, see if inside the logarithm is a positive value. So we have 4 plus 3 log of 2 times 5,000 is equal to 16. And that's a positive value, so yes, x equals 5,000 would be our solution to this. All right, now let's go ahead and try another example. Now, what about this one? Now here we have three logarithms. So they all have same base, but we're going to use the second rule for this one. So we have log of something equals to log of something else. We can just set the input equal to each other. So before we do that, you want to use the laws of logarithm to simplify this. So I have a plus in between two logarithmic expressions. I can make them into a product. So we have, using the laws, this is log of 5, base 5 of x times x plus 1 is equal to log base 5 of 20. Now using the law number, property number 2 above, we can say this is simply just x times x plus 1 is equal to 20. And now that becomes a quadratic equation that we know how to solve. So let's go ahead and distribute the x. So we have x squared plus x is equal to 20. And now I can subtract 20 to make it equal to 0. So we have x squared plus x minus 20 is equal to 0. Now something like this we can factor. So let's try to factor this. So we have x times x. That would give us, let's see, x squared. And then I can find two numbers to give me negative 20. They're summed to be a 1. So it looks like plus 5 and minus 4 would do the job. So that means I can set each one of them to 0. So we have x is equal to negative 5 and 4. So these are our possible answers, but now we have to check. So let's go ahead and do the check for each of the x values we got. So let's check. Plug into the original, so we have log base 5 of negative 5 plus log 5 of negative 5 plus 1 equals log base 5 of 20. Now, of course, after this, you can kind of stop because you cannot have a negative input inside the logarithm, so this wouldn't work. So this is a no. So this is not a solution. Now, what about 4? If I plug in 4, if I plug in 4 into the original equation, so we get log base 5 of 4, positive, that looks good. Now let's try the second term. Log base 5 of 4 plus 1, well, that's also positive. The last one doesn't have any x inside, so we just don't need to plug in anything. This looks good. So the only solution, it's going to be x equals 4. That will be the solution because when we did the check with negative 5, it didn't quite work. So that will be it. Now let's try another equation. Let's try to solve this one where we have natural log. Now we're still going to do the same thing, try to write this in exponential form and then solve for x. So I know the base is e for natural log, so we can write this using the definition e to the third power is equal to 2 plus x. And then we can solve for x by subtracting 2. E to the third, of course, you need to use a calculator, but we're not going to use it. We'll just leave it as e to the third power. So it's e to the third minus 2 is equal to x. So that's good enough if you're solving without a calculator. But if you have a calculator, go ahead and plug this in and that'll be your x value. And then if you plug this into your equation to do the check, you'll have ln of 2 plus x, that's e to the third, minus 2 is equal to 3. Well, yes, because if these cancels out, you have ln of e to the third, which is equal to 3. So the check also makes sense. So that would be our solution to this equation.